We've now come to our final session. Time to sort of breathe. And I'm really pleased to welcome Aparna Dhinakaran. And Aparna is the Chief Product Officer at a company called Arize AI, who are based in San Francisco and focused on model observability. And previously, Aparna was a machine learning engineer at Uber and Apple. So it's my absolute pleasure to introduce you to Aparna. Good morning, San Francisco.
Hey, good morning. How are
Hi.
you?
Really good. So, Aparna, I was just wondering, did you actually work with Mike Del Balso at Uber? I know you were both at Uber. I don't know if you overlapped at all.
I I I knew probably Jeremy better over at Tecton, but there were definitely some Uber ML conferences and such that we interacted at. So definitely know those guys. I think what they're building is amazing. I think that feature stores are super important, and as each of these pieces of the ML infrastructure start to become their own product, I think our solutions are complementary.
Okay, awesome. Well, Aparna, I'll leave you to it. Do take it away.
Cool. Well, thanks so much, everyone, for joining our talk on Arise and model observability in general. I think I'll start off with a little bit of background on myself, and then dive into why I think model observability is important, challenges with sort of putting machine learning in production today, and how observability can kind of help you transition to making those models successful in production. And we'll also go through some of the best practices for what to look for when your model is in production. And so a little bit of background on myself. Currently, I'm Chief Product Officer at a startup called Arize AI. We're based in Berkeley, California, and a lot of we're working with a number of Fortune 500 companies and startups across the ecosystem. And one of the things that really inspired me ultimately to start Arise was my background in being an ML engineer at some of these really tech first ML focused companies that we would launch and deploy models pretty regularly, and pretty often we would encounter an issue with model performance or data quality issues or downstream impacts to the business that ultimately almost felt like a little bit of a goose chase trying to figure out what was actually happening. Was it a data issue? Was my model not retrained in a while? Had it grown stale? What was really the core issue, and how do I ultimately troubleshoot and improve my models? I think I'm also deeply interested in sort of, especially with this world of sort of, AI becoming more and more, a decision maker in a lot of these businesses. How do we make sure that those decisions are transparent, fair, and we're responsible about, what we have control over and what we don't have insight into. So with that, I wanted to start off kind of giving, just an overview of kind of the current state and common challenges across bringing a model from research into production today. And we've heard a lot of great talks today from folks, across the ML infrastructure tools. But I thought I'd just give you, as one of the last speakers, just kind of an overview of, how I view the space. And there's a lot happening in this space, and there's a lot of nuance and complexity. But if I had to kind of break it down, I broadly view there's a set of companies that are really sort of focused on data preparation, making sure that the data that's actually entering into your models is processed, is clean. There's consistency in sort of how you process your inputs, and there's kind of a lot of work going on in sort of data labeling and data version control, and that's a really interesting space on its own. And then there's kind of a whole set of companies that are really focused on model building, and model building is really comprehensive. It includes things like hosted notebooks management, and you have companies that are really building the best in breed of hosted notebooks. You have folks that are really focused on model management, version tracking, and storage. And so weights and biases is one of these companies on sort of model management and version tracking. There's kind of a number of companies focused around just hyperparameter optimization. And so you get the point. There's kind of a set of companies that are building and focusing on the really rapid experimentation flow of sort of just building your models. And then there's a set of companies that are really focused on, once that model is actually built, you're okay with that performance and sort of a, your validation environment, what you've actually tested your model on, and are now trying to make that leap of bringing that model outside of the research environment into a true production environment. And there's companies that are focused on sort of, how do I deploy and serve this at scale, interact with a number of different teams and handle security issues. And I think a big player in that space is obviously SageMaker. Algorithmia is another big one, but a lot of companies really focused on the deployment and serving. And to be honest, that's kind of where a lot of the noise kind of a lot of the noise in the last 5 years has really been, how do I build my model, maybe even how do I prep my data, and then ultimately, how do I serve it? Like, how do I get this into production? And I think the more and more we've talked to over maybe 500 companies in the valley that are deeply using machine learning for kind of their core processes and what their business really stands on. And one of the things they're consistently met with is, I've deployed the model in production. Now I'm seeing some results, or here's kind of the performance of my model. Now what? How do I go and debug any issues that come up with my model? How do I first even know if it's working? There's almost like this lingering piece of, how do I ultimately feed back into the loop of continuing to iterate on my model and build and make better versions of my models? And that's really where model observability comes in, is, similar to kind of software infrastructure monitoring, we really think about sort of the need for model observability as kind of, bringing all of the, the complex pieces that come into making a model successful in production, the inputs and the outputs and the actuals, and how do you have a unique platform to view the results in a consistent way, troubleshoot in a consistent way, explain your decisions, and really ultimately feed back into the piece about data preparation and improving your models. And just really kind of focusing on, what that journey today looks like from research to production, and getting a little deeper. Today there's kind of, set of folks who, sometimes it's the data scientist in an org, sometimes it's an ML engineer, who ultimately, once that model has been built, they're tasked with sort of bringing that model into production. And at some some of even my old previous jobs, sometimes that could involve entirely rewriting that model from sort of this research code. Sometimes it's in R, or maybe the model environment that you're serving in is in Java, but you built your model in Python. There's almost sometimes this entire rewrite process of, how do you make this model actually scale as it's entering production? And so a lot of opportunities for sort of differences in what you actually built in research and differences into what you actually built in production. And the data that you're working with in sort of a research environment can often be this really cleaned and really processed data set that you might not actually see in production if your feature pipelines aren't as robust as you'd like them to be. And so a lot of issues around data changes. The feature might be different in production. There might be instances of data leakage where you're training your model on a feature that you might not actually see in production until much later down kind of the time. If you're using kind of aggregate performance to evaluate if your model is performing well in a research or pre-production environment, as you dive into production and you start to get complaints from a specific region or specific cohort or predictions, really not knowing how your model is performing in sort of a different slices is something that's really not considered as you're really launching that model into production. And oftentimes there's almost like this, a team member writes these set of scripts as sort of, here's these model validation scripts, make sure you run these before it actually enters production. And the team member leaves, or there's a new version of the model and those scripts are broken. It's almost like this constant maintenance of, how do I actually validate that this model that I built is actually going to be successful when it's ultimately in production? And so if you get through all of that hoopla and you're finally able to launch that model into production, there's there's still issues around feature drift, performance drift that can happen, not being able to look at your performance across individual slices, not knowing, how to troubleshoot your model if issues around performance or, drift come up. And really, I think we've heard this almost unanimously across a number of companies that we've spoken to, but set of, again, these ad hoc manual scripts to sort of help you, constantly troubleshoot how your models are actually doing in production. And for some folks, it's, who are maybe on the more, advanced end, maybe have, some kind of snapshot view of their model performance, or, every day are looking at sort of a overall aggregate view of their model performance, but really not having the tooling to be able to dive in when really there's issues that occur in production, just like they do with software. And so I guess my point of sort of bringing this view of sort of what the journey looks like from research to production is that it's pretty difficult, and making it work continually is not something that's automated in a lot of ML teams today. In fact, it's a lot of manual oversight, folks diving in and ad hoc trying to find issues, and not knowing if there's simmering things that are lying underneath that they're not able to identify for weeks, months, if not years. And so what that really boils down to on kind of, if I had to boil that slide down to kind of three main points that, or pain points that folks have across ML teams, it's really, hey, how do I know if this model that I've built is actually going to work in production? I've tested it in a validation environment. I think that my performance is okay in this environment, but is there any way, how do I actually, have a reference distribution to test, that this model is working? How can I actually, compare this to kind of if I'm doing kind of a challenger and champion model approach, what's actually kind of my, the test sets that I'm going to validate it on? How do I actually know how this model is doing compared to the one that I might already have in production? And there's a series of tests that, you want to look at before you actually are sure that this challenger model is the one that you ultimately want to promote into production. The second set of questions is really kind of around, my model's launched, it's in production. And if you ask some data scientists or ML engineers on your team, hey, is my model working? Is it doing all right? It's pretty hard to get a clear-cut answer on, hey, what's my model doing in production? Is it working? And we talk to folks, VPN, CTOs who have said things to us like, I'm spending millions and millions of dollars on machine learning annually, and I really have no idea if it's even working. And so how, and this isn't really just an issue that comes from the top, but even on the folks on the ground, the data scientists and the ML engineers and other engineers who are on the team, how do I know if I'm seeing an issue because of a model performance issue, if it's because of a data performance issue, is it some software bug? How do I really know not only how my model is working, across the entire USA, but really just maybe I'm looking at performance in just California? And so how do I really be able to troubleshoot across different slices and cohorts is something that's a common concern for folks across the ML teams we've spoken to. And lastly, knowing that there's an issue and then being able to get to the root of what's actually wrong with my model. How do I go troubleshoot? These are the key, inputs that my model's not performing well on, or key slices where performance is decreased. Why has my model made a decision in this specific, prediction that seems off or is consistently wrong? And so, how do I bring more and more of explainability and reasoning around, real reasoning around what's wrong with my model? Let me identify issues with sort of why my model's performance is going down or my features drifted, and ultimately drive that to how do I improve my model and build on better versions of my model. And if we look at kind of the current model of folks who, the time that's spent in current ML teams on, when they're actually building models, when they're actually, just kind of wrangling the data, and when they're actually dealing with just operational issues of trying to get their model into production and actually, and actually make sure it's successful, that time today is really kind of, a huge chunk of their end-to-end workflow. takes up about 30% of their time to just, consistently, not even after that model is deployed, to consistently make sure that that model is working, it's operating as expected in production. And it's something that we feel is very ad hoc and manual today at Arize. And a lot of the folks, in terms of kind of ML observability as sort of a pyramid, what tier that we see most folks are on is really kind of at maybe a level one. They're able to view kind of model performance in an aggregate. They're able to sometimes identify, when there's missingness or when there's data quality issues. But really, getting to the point of where are my problems, point me to where are areas that my, slices where my model is not performing well. Tell me exactly, what are inputs to my data that are constantly, causing an issue. Are there any data quality issues? Give me a reason for why my model has made a decision is pretty tough today. And most folks are really not at that level of sort of where even are my problems. And then the next level we want kind of, as you move up the stack of sort of automating away ML observability and giving back the data scientists and ML engineers their time, apart from just identifying where the problem is, how do you fix those issues? How do you improve your model? And ultimately increase the speed of sort of your ML teams and increase the modeling velocity is what we really care about at Arize. And I think teams that are really focused on sort of, how do we bring more ML observability into our company? And, there's a broad set of issues, and I'll dive into each of these as we kind of walk through the platform and talk through kind of the challenges that the folks have. But, I did want to kind of, just ask folks who are listening and chiming in, what are some of the biggest production challenges that you think about? And Nic, this might be a great time to run the poll, but we see a broad set of sort of production challenges that the folks are really worried about, things such as model drift, which includes performance and feature drift, data distribution changes, not knowing if there's unseen values for a feature, black box models, if kind of you want to understand and get to the root of why your model made a decision, and really kind of understanding the kind of explainability behind your models. And lastly, last two kind of part of a broader set is really kind of how do I identify data quality issues? How do I make sure that there's not a set of uppercase values that are coming in when I was expecting lowercase values? And some of these are issues that sound really trivial to talk about, but when you're running a production system, these happen all of the time. And how do I consistently make sure that that feature encoding and upstream data changes are truly what they're supposed to be in a production environment? And lastly, model readiness. As you start to iterate on models, just like we iterate on software, how do you really compare different versions of models against each other, know which one to promote, and how do I make sure that before I add any changes to sort of the state of this model, that I'm really ready for kind of the changes that's coming. And so Nic, I wanted to ask if there's anything I need to do on my end to run the poll right now.
It's been posted, Aparna.
Oh, great. Okay, cool. Maybe I'll just hold off on this slide while you run that poll.
Ref.
And so what I'm just really interested in is for folks who are tuning in is really, what pieces of model observability are important to you or have come up in discussions around, how do I identify and troubleshoot my models? And I'm curious about if any of these conversations have been happening in the orgs that you guys are in.
confusion there, Nick. You can't hear her because she's not talking. But she's basically...
Sorry, yeah.
Oh, can you hear her now?
Hi, Aparna. Hi. Yes. So
Yeah.
I can see the poll, but I can't see the results, unfortunately. So you might have to just continue on.
Oh, okay, that's totally fine. I was just didn't want to just interrupt if you guys were going to post the results, but I'll keep going, and we can get back to it. So,
Yeah.
you know, these are a set of kind of common production challenges that we hear about all the time, and there's a broader set around sort of, you know, ML fairness and include kind of a set of other challenges. And you know, just diving into maybe a specific sort of challenge that I showed on the other slide around, you know, data distribution changes, and really just giving you a concrete example of what a data distribution check really looks like. You know, if the yellow bars, if you can think about them as sort of your predictions that were made this week in production. So these are kind of the predictions that you're making this week, and you know, if they're kind of a numeric distribution, let's assume they're kind of binned by some quantiles, or they're binned by some kind of you know, distribution that you want to see it on. There's a lot of reference distributions that you might want to compare this predictions this week to. You could compare it to, you know, the distributions that you saw when you initially launched the model, and this gives you kind of an overview of, you know, if it's been a, you know, 6 months since you've launched your model versus, you know, what your distribution looks like today. There could be some indication if the distributions are different, that there's some you know, some proof for sort of there's been some drift in sort of what your model is predicting today versus when it was initially launched in production. There's a reference distribution that you might want to set against your training data set. And so you're able to compare, you know, here's the, you know, this might be one that makes better to do with, you know, sort of feature inputs that you're looking at. And so, you know, here's the feature inputs that I saw when I was training my model, and here's the feature inputs that I'm seeing in production today. And that gives you an idea of sort of, you know, here's maybe some drift in the inputs that are actually coming into your model, and whether you need to trigger a retrain, or, you know, train with some new values that include kind of a more recent, you know, recent look at the features that are coming into your model. There's also a set of sort of, you know, a validation set that you might want to compare your models to. The validation set, you know, if you're stress testing your model on sort of, you know, set of unique circumstances, or, you know, a change in the world scenario. So some folks, you know, test their models on kind of, you know, if this happened, what would my model predict? And so, you know, especially in the times of COVID, and really kind of, you know, models kind of going whack, stress testing your model and having a validation set that you can compare your model performance to gives you an idea of sort of, you know, here's what I've trained if these were the environment conditions, and here's what my model is actually doing. You can compare your model against last week versus this week. And so you're always kind of looking at sort of a week by week model performance comparison, really looking at, you know, are there any outliers and anomalies, any major events that could have happened between my distributions that I'm looking at this week versus last week. And lastly, as I'm looking at things such as, you know, my, you know, upgrading a new version of the model into production, or A/B testing two different models live, comparing the distributions of, you know, what my model is predicting on either ends of those models is really crucial to figuring out which one do I ultimately promote into production. And so, you know, there's a lot of things that you want to dive into and look at when you're looking at data distribution changes. And some of the things that we recommend are really kind of, you know, pick your statistical distance check that makes sense. And so some folks in finance, PSI is really common. You know, we kind of support PSI, KL divergence, Earth movers distance, you know, Shannon Jensen. And so there's kind of a set of statistical distances that make sense for certain distribution changes that you know, you want to look at as your model's evolving over time. And, you know, as I sort of just, you know, hop into what we're building and what an observability platform looks like today, I thought I'd just take a second to really, you know, summarize why you know, the ecosystem and the time is sort of changing, and more folks are investing in kind of, you know, I need observability, I need monitoring for my models, I want to understand what they're doing. And, you know, I think it really kind of boils down to some of these kind of core reasons. First is really, once you've been bitten a couple times with, here's what my model predicted, it cost me $1 million, or, it lost me a customer. My demand models, my forecasting models weren't as great as my competition. And ultimately, maybe that's what you're really worried about. And so how do I really catch problems before my customers catch them? And how do I, make sure that I'm aware of my model changes before my downstream users are? Second, today there's really kind of weak visibility into core business metrics, such as, hey, how's my fraud detection model working? How do I know what certain regions or areas that my model performance is really impacting my business? And so how do I transition going from model performance into business metrics, making sure that there's kind of a real key connection from model performance directly into impact? Today there's a lot of kind of, it could be model performance issues. It could also be software mistakes or data quality issues that causes, garbage to come into the models, garbage to come out. And so actively, robustly monitoring what's going into the models, the inputs, what's my model actually predicting, what are predictions that I need to go and follow up on and check to make sure that these are a set that don't make sense is really important. And lastly, every live model that a team actually maintains in production and is manually and ad hoc, whether you're doing daily sanity checks or consistently, trying to identify issues and find simmering issues, slows down the velocity of a team. And so how do I ultimately deliver models with speed and confidence like we deliver software? And so with that, I'm going to give you an overview of Arize, share what we're building, and leave you guys with maybe a little bit of a demo. The team at Arize really comes from folks who have worked on ML infra at a number of these companies and have also really deeply been in the analytics space. And so the team kind of is a little bit of ML infra meets analytics, and we're building kind of the best observability, product for machine learning. And the goal with Arize is really you take all of these complex moving pieces across the data pipelines that are going through the model from a validation environment, the data, metadata that's flowing through, features that are being passed into the model, whether they're one-hot encoded, whether they're kind of the raw features, the predictions that the model is making, and then the actuals. And these are all just in a validation environment before your model is even deploying to production. And you have those same things in a production environment too. You have your metadata, such as, if you're running a different model for a different region, if you have, certain features that you want to explain why you pick that specific input for the model in production. Some folks send even the hyperparameters that they want to make sure that they tag with that model. And so how do I pass in sort of, here's kind of a set of metadata, and then here's a set of raw features, raw data that's coming to our platform before the features are processed. And so how can I catch any issues that are going on even in that sort of feature processing layer? And so the raw data that's coming in, features that are going into the model, the inputs, the predictions that the model's making, and then the actuals that you might fetch back. And I'll dive into actuals, but really, it's kind of, if your model's predicting something in a case such as, fraud or not fraud, you might not find out if that prediction was sort of actually fraud or not fraud until sometime later. And so how on our platform, we enable kind of, you can send the actuals with some delay. For some folks who are using us, 60, 90 seconds. For other folks, it's upwards of 90 days. And so how do you tag back the actuals and ultimately kind of, bring all of this complex information that's coming in at different times, different intervals, and build a simple tool that answers a couple of questions. Hey, is my model working? Is it performing okay? Where can I go look to improve my model? And why did my model make a decision? That's really kind of the simple questions that we want to help you surface up and answer in a really quick way. And the way we do that is, we capture these inputs that are going into the model, the data, the features, the predictions, the actuals, and based off of all these signals that are coming into the model, we've built a platform that does things like distribution checks, feature analysis, looking into your prediction quality, and real-time model performance tracking and alerts. And so all of these things are identifying, notifying you when there's drift or there's changes in what's occurring, as opposed to, you manually going in and figuring out if some feature has drifted from the time you launched your model to the time it's actually in production. The way we're set up is really kind of, think of kind of like a Datadog approach. You drop in our agent, a little piece of our, our SDK, whether you're using kind of Python or Java or kind of another SDK that we have. You drop our code into your serving or your model deployment infrastructure, and we pick up kind of all of those signals, and we built a platform that gives you all of those features of an observability platform. And so the way we're really built is to be agnostic of the platform you're actually serving on and the model that you're actually integrated with. And this is something that we think, you've heard from other talks today with sort of Selden and Tecton, and just lately with Pachyderm. And so, really these kind of verticalized solutions, they're built to integrate across the stack. And so they're built to work with the other tools that are in your toolkit. Cool. Well, I'm going to hop into a little bit of a demo just to give you guys an overview of kind of, what we're kind of building and what you might want to look at as you're kind of considering a model observability. And we'll talk through an example and a demo so that you can get an idea of, how do you really can you make troubleshooting easier in kind of using a platform. So one of the things that comes in really quickly is, there's a set of dashboards that you can set up across your models. And, for some of these, they can be, validation sets. For some of these, you might want to compare different models against each other's. I set up kind of a dashboard that's specifically for this conference, but you can set up dashboards based off of the models that you've sent in. You can see the versions live for kind of the models. And really simply, if let's say I've sent in a model, maybe it's a loan fraud model, really quickly, in the past, you probably are sitting around and setting a set of alerts and setting kind of, set of dashboards that you need to understand what to actually monitor. On our platform, something you can really quickly do is go in and select, I want to set up a loan fraud model, and monitor that model and set up just a really quick template for me to go in and monitor this. And so I can pick my model, since this is a multi-classification problem, what are the classes that I want to make sure I look at, common evaluation metrics based off of things like recall, F1 score, and maybe I want to pick some top features that I really care about. And so in this case, maybe I want to look at, the state that this prediction came from, home ownership. I could look at something like purpose of the loan. And, there's kind of a set of, top or key features that you can select as you're kind of creating a dashboard. Really quickly, you can set up a dashboard. You can take a look at sort of, maybe I care about the last 90 days of performance. Maybe I want to look at sort of the aggregate view of sort of the performance. And so really quickly set up kind of a dashboard that looks at things like inputs that are coming in, overall accuracy, what do my predictions versus actuals look like? Here's the daily count of predictions. I'm getting accuracy by class, common evaluation metrics by class. I can break it down into the specific classes that we picked earlier on. So what is my recall just for fraud? What is my false negative score just for fraud? And I can get a quick look at sort of the key sort of features that I'm interested in. And as I'm debugging, and maybe I have a couple of these dashboards that are set up for each model, I could also go in and slice every single one of these kind of widgets or kind of charts and distribution graphs on my dashboard really quickly at the very top. And so I can go in and want to look specifically at the predictions that are made in California. And, really quickly, all of my predictions are sliced just where, the prediction was made in California. And so, really quick ad hoc ways to get you to slices of predictions, understand, hey, it looks like there's some dip in California during this time region. why did this happen? And it's something I won't show you here on this demo is really, the kind of the next set of cool things that we have launched and using is, if I really care about why this area dipped, I can click into it and go into sort of a view of, what are the features that brought this performance down specifically in this time window. But even with just kind of this view, I can kind of compare, what is, performance look like just for California. I can also, specifically, on each of these widgets, go in and look at general model performance and just kind of, what the feature looked like on sort of a general view, and also what the feature looked like specifically for a specific region such as California. So in this case, I can take a look at sort of, what is my feature purpose, not only look like in kind of an aggregate view, but also what does that look like only in California. And so I'm going to find address state. Oh, it's because I gotta pick the model. Live demos. And so, I can take a look at sort of things like maybe I only want to look at sort of, what the loan looks like for a specific home ownership. And so, there's kind of a set of, not only are all of these kind of widgets things that you can look at in sort of a general view, but also on a slice by slice kind of view. And so, I think we're running out of time, so I'm going to kind of hop back into kind of the slides, but I just wanted to give you guys a quick look into what how you can really quickly set up dashboards, really quickly do slices. And there's a lot more that I don't have time to show you, but thought we'd at least kind of get started on it. And I think, if any of you folks are kind of interested or kind of interested in kind of getting early access to the platform, feel free to reach out after the talk. Happy to kind of run through and talk about sort of, what are a broader set of things you can do on the platform. I think I have a couple minutes left, so I'm going to hand it back and Nick, leave some time open if you have any questions and want to talk through what we've been chatting about.
Hey, Aparna, thanks so much. And we do actually have the poll results I can share with you for what it's worth.
Awesome. Yes.
So the question you asked, Aparna, was what is the most important for your model observability? And we had model drift was 0%, data distribution changes 21%, model explainability was 21%, and then joint tie was model bias and fairness 29%, and model readiness, so challenger model and canary testing was 29%. So yeah, that's of interest. And we do have a couple of questions. Probably got time for probably just one question, if that's okay.
Absolutely.
So Mike Moran, thanks for your question. So Mike is asking, how do examples like customer funnel changes fit into this framework? For example, if your model is used for results ranking and something upstream in the funnel flow changes due to a change in the product itself, which changes the customer context in which your model is applied. So his question was, how do examples like customer funnel changes fit into this framework?
That's a great question. And earlier I was talking about sort of pieces like metadata or pieces, the other sort of information that you might want to slice and dice your model performance on. And so something like, the customer funnel that you might be something that you might actually want to slice your model performance on, and you can pass that in when you're logging the model predictions or inferences to our platform. And so, a broad answer to this is, just because it's maybe not a core input to the model or a direct input to the model doesn't mean it's not something that you can log. We have folks who log a set of things that are happening all across their feature pipeline. And that's something that, they really care about being able to look and slice and dice on.
Okay, great. So Aparna, presumably you'll be around for some more questions if people want to reach out to you directly.
Absolutely.
Great. Well, thanks so much for the presentation. We're out of time today. That does actually wrap up the show. So Aparna, thank you so much for being involved. Well done.